Hello scholars, it is Miss Breeding. I have my notebook on the screen so you all can see exactly the work that I'm doing to make sure that you understand. Today we're on lesson 12, and our goal for today is to be able to solve word problems that involve area. So any type of word problem that requires us to find the area, we should be able to solve at the end of this lesson. Let's start with our application problem. Your page should say lesson 12 application problem at the top. So part A, it says find the area of a 6 meter by 9 meter rectangle. Go ahead and take a couple of seconds to underline important words that you see in this problem. Alright, so these are the things that I found that were very important. I know that I have to find the area. I know that my two sides are 6 meters and 9 meters, and I know that my shape is a rectangle. So let's go ahead and draw our rectangle so we can see it to make sure we find the accurate area. Okay, so go ahead and take a moment to think about which side would make sense to be 6 meters and which side should be 9 meters. Go ahead and label it. On my page, I have 6 meter on the short side because 9 is a larger amount of space than 6 meters. So 9 meters is longer than 6 meters. So that's why I have the short side is 6 meters and the long side is 9 meters. Are we done with our problem? No, we're not. The first thing it tells us to do is find the area. So we know our two sides are 6 and 9. So in order to find the area, we're going to multiply 6 and 9. Area equals 6 meters times 9 meters equals how many meters? On the count of 3. 1, 2, 3. That's right. 54 meters. We figured it out by multiplying the two sides together. Okay. If you have any questions about how we solve part A, please write that down so I can check it in your packet. Moving on to part B. This one is a little bit more wordy than part A, so let's go ahead and read. I'm going to give you about 30 seconds. Read and underline important words. Alright, scholars. So let's read this together. Use the side lengths 6 meters times 9 meters to find different side lengths. I think the word different is important because now I know that when I do look for my side lengths, they cannot be 6 and 9. Okay, so it's very important for different side lengths to be underlined. We have to remember that. For a rectangle, I know what type of shape I'm using that has the same area. Okay, so from this first sentence, I know that I'm making a rectangle with different side lengths that has the same area as my rectangle from part A. So let's go ahead and write what our area will equal. What is our area? If it's the same as part A, what is our area? That's right, it's 54 meters. Please be sure to include your unit here. Let's read the next sentence. Show your equations using parentheses. So now we have to take this equation and create different side lengths for our new rectangle that still has an area of 54 meters. Lastly, it says estimate to draw the rectangle and label the side lengths. Okay. So the first step we're going to do, what do you think the first thing is that we need to do? Do we need to draw our rectangle first? Do we need to figure out our new side lengths first? Or do we need to make our equations? I believe we should start with our equations. Let's go ahead and get that out of the way so we know our side lengths, and we can save the easiest part last to draw our rectangle. So our new problem, or our problem before, was 6 meters times 9 meters equals 54 meters. So we pulled that from right up here, from part A. Now, to make it easier, and since we have to play around with numbers, let's get rid of the unit right now. So 6 times 9 equals 54. So remember when we were having to use the distribute and break apart strategy? Sometimes we would have to break down a number into smaller chunks. So would it make more sense for us to break down 6 or for us to break down the larger number 9? Take a moment to see if you remember that. When we're breaking down a number, does it make more sense to break down the larger number or the smaller number? If you guess larger number, you are correct. So we're going to keep 6 the same. We're still multiplying. Now we need to break 9 down into 2 parts. Think about a multiplication sentence with 2 factors that equals 9. Blank times blank equals 9. 3 times 3. Okay, and we're going to keep that at equals 54 because remember we have to have the same area. So no matter what combination we come up with next, it has to equal the same area, which is our 54 meters. Next, we have to show our equations using parentheses. So at first, we had 6 times 9. We kept our 6 the same, and our parentheses would have been around our 2 3's. Now we need to shift our parentheses over here. What is 6 times 3? That's right, 6 times 3 is 18. And we're going to bring down our times and bring down our 3. And this still equals 54. So we don't have to try to skip count by 3 18 times or skip count by 18 3 times because we kept our area the same. We did not change any numbers, or we didn't change the value on either side of our equation. So have we found our different side lengths? Yes, we have. Our new side lengths are 18 and 3. Okay. Did we show our equations using parentheses? Yes, we did. We broke down our 9 and shifted our parentheses to the left. So we now have 6 times 3 times 3, which is 18 times 3. The last thing we need to do is estimate to draw the rectangle and label the side lengths. Estimate just means to draw a rectangle that you think looks like 18 times 3. I'm going to pause my screen and I want you to draw your own rectangle before you look at mine. I'll give you about 30 seconds to draw your rectangle and label the side lengths. Bring it back in 5, 4, 3, 2, 1. So here's my rectangle and I'm about to label my side lengths. I want your help though. I have the numbers 18 and 3. So which side makes more sense to label 18? 18 is way larger than 3. So one would be here, the other will be here. I believe this long side with the width of the rectangle should be 18. Don't forget your unit, meters. So this side will be 3 meters. Okay. If you have any questions about how we solve part B, please make sure you write down your questions so I can help you. All right. moving on to our problem set. Number 1, it says each side on a sticky note measures 9 centimeters. Let's go ahead and draw our sticky note. We all know what sticky notes look like. Okay? Each side is 9 centimeters. 9 cm, 9 cm. What is the area of the sticky note? Go ahead and solve this problem. You have 15 seconds. Three, 2, 1. You should have 9 centimeters. Ms. Breeden almost forgot her units. 9 centimeters times 9 centimeters equals 81 centimeters. Okay, let's move on to number 2. Stacy tiles the rectangle below using her square pattern blocks. Let's go ahead and find the area of this. We have this side is 3 units. And this side is 4 units. Find the area of Stacy's rectangle in square units. Let's find that area. Area equals 3 units times 4 units. That equals 12 units. Then draw and label a different rectangle with whole number side lengths that has the same area. This is the exact same thing we did for our application problem. So we know that our area has to equal 12 square units. 12 square units. So I want you to think of a number combination that would equal 12 square units. What are 2 numbers that can be multiplied outside of 3 times 4 that equals 12 square units? Take a couple of seconds to think. Blank times blank equals 12. Bring it back together in 5, 4, 3, 2, and 1. Okay, so I came up with 6 times 2. So I am going to draw my rectangle with showing 6 units times 2 units equals 12 square units. I'm going to label my 6 for my short side, 6 units, and then my 2 for this side. Now, did I label that correctly? No, I did not. Remember, we want our longer sides to be with our larger numbers. So let's label the other sides. This side will be 2 units. And this other long side will be 6 units because it's larger. 6 units times 2 units equal 12 square units. All right, let's go to part B. It says, can you draw another rectangle with different whole number side lengths and have the same area? Explain how you know. Remember, this is a very important piece. Explain how you know. Okay, so are there 2 other numbers that can be multiplied together to give us 12 square units? Take the time to think about it. Back together in 5, 4, 3, 2, 1. What did you come up with? I came up with 12 times 1. That still will give me a total of 12 square units. So let me draw my rectangle. My larger side, is it going to be side A or side B? Where am I going to put 12? I will put 12 here on the larger side, 12 units. And on this side, I will have 1 unit. 12 units times 1 unit is 12 square units. And this is our area. Okay. Next page. All right. Change my book. All right. Number 3. An artist paints a 4-foot by 16-foot mural on a wall. A mural is a picture that someone paints or draws on a wall. What is the total area of the mural? Use the break apart and distribute strategy. So remember, our break apart and distribute strategy is when we take a larger number and break it down. Okay, so the original measurement of the wall was 4 foot by 16. 4 times 16 can be a little bit difficult for us to figure out. So our problem has actually given us the break apart and distribute strategy already. They broke 16 down into 10 and 6. Do we know what 4 times 10 is? That's an easy one. What about 4 times 6? I believe we know the answer to both of these. Let's solve. 4 times 10 equals, that's right, 40. And then 4 times 6 equals 24. To find our total area of the mural, which is our question here, the total area, we're going to add 40 and 24 because this side is 4 times 10 and this side over here is 4 times 6. 10 is the larger part, 6 is the smaller part. 0 plus 4 equals 4, and 4 plus 2 equals 6. What is our unit? 6 square feet. Okay, let's move on to number 4. Elena tiles the 3 figures below. She says, I'm making a pattern. Part A. Find the area of Elena's 3 figures and explain her pattern. Go ahead and take about 2 minutes. Take 1 minute to find the pattern. See if you can figure out what the pattern is that Elena has. And then try to answer part A on your own. All right. What patterns did you all find? The pattern I saw was each side goes up by 1. So for an example, this side is 2 by 2. This side is 3 by 3. This side is 4 by 4. Okay. So when it says find the area of Elena's 3 figures and explain her pattern, I know the area of this one is 4 because 2 times 2 is 4. The area of this figure is 3 times 3, which equals 9. And the area of this figure is 4 times 4, which equals 16. Okay? Take the time to look at that if you're confused. Next, you have to explain her pattern. So the pattern is that the number of tiles on each side increases by 1 as we go up. So for an example, the sides here were 2. The sides here are 3. 3 on each side. That's 1, 2, 3, 1, 2, 3. The sides here are 4. 1, 2, 3, 4. Then 1, 2, 3, 4. Okay, so here we're going to write the pattern is that the side lengths increase, that means goes up, by 1 tile. The side lengths increase by 1 tile. Okay, so the length of each side increases by 1 tile. Part B, it says draw the next 2 figures in Elena's pattern and find their areas. So I'm going to pause my screen. You will have about 1 minute to write the next 2 figures. So let's talk this out. So this side is 2, this side is 3, this side is 4. Our next side lengths are going to be 5, and the one after that is going to be 6. You want to make sure that each side has the even amount. So if this side has 5, the top side has to have 5 too. If the length is 6, the width needs to be 6 too. Remember, all squares have the same length and width. You have 1 minute. Bringing it back together in 5, 4, 3, 2, 1. All right. So here are my drawings here. So remember, these sides were 4. My new sides, I had to draw the next 2 figures. So if this one was 4, my next one had to be 5. Let's count. 1, 2, 3, 4, 5. That side is correct. Let's count the top side. 1, 2, 3, 4, 5. Okay, so this is a 5 by 5 square, and our total area is going to be, on the count of 3, 1, 2, 3. That's right, 25. What's going on this red? I'll record. It's okay. It's okay. My next side. The next side is going to be, let's count. 1, 2, 3, 4, 5, 6. And then let's count the top side. 1, 2, 3, 4, 5, 6. So this side is 6, this side is 6. So we're going to multiply to find our total area. 6 times 6 on the count of 3. 1, 2, 3. 36. Now, is there something that I left out of each of these areas? Think about it. There's something that I always tell you to include when we're finding our areas. Let me give you a hint if you don't already know. If you know, go ahead and make the corrections or add to it. If not, here we go. It should be 4 square units. 9 square units. 16 square units. 25 square units. And 36 square units. Okay. Always remember our units. Okay. Let's go on to number 5. This is our last problem before our application problem. Remember, your application problem is just like a test. So make sure that you are working on the problem independently. No, you may not ask mom or dad or grandma, brother, sister for help. You must complete your exit ticket on your own. This is your chance to show what you know. So if you are confused by anything, please rewind after we complete number 5 to make sure that you understand. Go through it as many times as you need to understand. Okay? Let's get ready for number 5. Jermaine glues 3 identical pieces of paper as shown below to make a square. So this is piece 1, piece 2, piece 3. Find the unknown side length of one piece of paper. Then find the total area of 2 pieces of paper. So the first part, we have to find the unknown side length of one piece of paper. Then the second part is we have to find the total area of 2 pieces of paper. So let's go ahead and break down what we have here. So we know the width of each piece of paper is 9 centimeters. So for each sheet of paper is 9 centimeters wide. The total length for all 3 pieces of paper is 9 centimeters as well. So what is each side of each individual piece of paper? How long is that? If all 3 of them are 9 together, we have to divide that 9 into 3 parts. So what's 9 divided by 3? 9 divided by 3 is 3. 3 times 3 equals 9. So the unknown side length of one piece of paper is 3 centimeters. Let's go ahead and write that for each side, 3 centimeters. Okay. Next, it says find the total area of 2 pieces of paper. So let's first find the area of one piece of paper. One piece of paper would be 9 times what? 3. 9 times 3. So what would be the total area for 2 pieces of paper? Go ahead and write the equation out to the side on your own. You have 30 seconds. Go. All right, so we know that one side or one piece of paper, one piece will equal 9 times 3, which equals 27. 2 pieces of paper will equal 9 times, say it on the count of 3, 1, 2, 3, 6, which equals 9 times 6, 1, 2, 3, 54. And then the total area, let's do all 3 pieces. And I know this is doing a little bit extra, but why not challenge ourselves? It'll be 9 times what? 9, because we already know all 3 pieces of paper are 9 centimeters. 9 times 9 equals 81. All of these units should be centimeters. 9 centimeters, 3 centimeters. Cannot forget our units. Okay. So next, if you at this point, if you have not understood everything we have done, I want you to go back and review. Next, you have your exit ticket. I am very confident that you all are able to do this on your own. We have, in our problem set, we have done much more difficult problems. So take your time, read the problem. I'm looking to see who underlines important words, who shows their work. Remember, you do not get credit if you do not show your work. And also make sure that you include the units. See you next lesson.